Welcome back, everybody. Let's go ahead and take a look at the last stated in geometry questions for 23I. Congruent isosceles triangles may be grouped to form a shape similar to a circle. The more triangles we put in there, the more it looks like a circle. And they tell us that the sum of these areas is going to be n times all this junk, where n is the number of triangles in the question and r is the radius of the associated circle it's trying to make. The question is, what is the smallest n for which the sum of the triangle areas equals the circle area with just smaller than 1% error? Okay. Well, we're essentially going to be doing a solver here of percent error. It's going to be the correct value minus the guess value all over the correct value, where the true value here would be the area of a circle of radius pi r squared. Now, what you'll notice is that they didn't give us a radius. It doesn't matter. Because of the ratio here, both terms on the top have an r squared, and that's going to cancel out, so it doesn't matter. So it becomes the area of the circle minus the area of that approximation. We just slap in that formula as they gave it. Now here, we're going to want an error less than 0.01%. So my understanding is you can, if you don't put the negative here, or if you forget it, you're going to go on the underside. So let's just make sure. The correct value should be smaller. No, the correct value should be bigger, right? Yeah, it should be bigger. I'm sorry, I'm like losing my train of thought. I haven't had my coffee. But I'm sorry, the straightforward point right now is just to get this video done with, I'm so sorry, is do it with a minus 0.01, do it with a positive 0.01, and choose the bigger n value, right? Because the, man, forget what I said. Anyways, load it in here, and then you guys are smarter than I am right now, so use your better judgment, and then we can look at the key. I'm so sorry. 62 is our overflow. Whatever. You guys are very gracious when I make mistakes, so I should chill out, right? Anyways. So 62, what is 5 to the 5 to the 5? What we need to understand is that we can take the 5 to the 5 on the exponents and combine them. So it's really 5 to the 25, and that's an overflow. We've talked about overflows. They have a very specific algorithm for solving them. The idea is that you use logarithms to rewrite the number. The logarithm is going to bring over the 25 to the front, and it becomes 25 times log of 5. Your calculator is going to spit out a number that is going to be like a bunch of digits, then a decimal place, and then more digits. The digits in front of the decimal place are called the integer part, and the digits after the decimal are called the fractional part. Well, it turns out that if we raise both those parts to the 10, or right, we raise 10 to those parts, then we have our answer. And so our answer is going to be 10 to the fractional part times 10 to the integer part. And you write it just the way you normally would in calculator. Number 63, a professional golfer hits a golf ball with 250 yards with a 4-iron. They tell us the release angle of a 4-iron is 24 degrees. And the question is, how far would the golf ball travel if she used a 5-iron instead? And the release angle of a 5-iron is 27 degrees. Okay, let's go ahead and take a look over here. 63 is almost always going to be a trajectory problem. Now, there are many formulas for trajectories, but two that I recommend you guys memorize, and you probably didn't cover them in physics, maybe you did, are going to be maximum range and maximum altitude reached by the projectile, assuming it lands at the same elevation. So you only ever use these formulas if we take off and land from the same height. If this thing hit, stopped at the top, we wouldn't be able to use these expressions properly. Okay. So they tell us that the maximum range is 250 yards or 750 feet, and we're going to need the acceleration due to gravity in feet per second squared. That's going to be 32.17. Now don't worry about the negative here, okay? We're just getting magnitudes or the size of the number. So what do? Well, we need to find the initial launch velocity. They tell us the range, we know the launch angle, and the acceleration due to gravity. So the first thing we do is we solve for the velocity when the maximum range is 750. The next thing is we're going to use the equation again with the velocity and the new angle of 27 degrees to get max distance 2. And that's it. It's just how far will it go, not even how much further. 64. 64 looks very intimidating. And it can look, but it can be pretty easy if you know the right formulas. Now, what are those formulas? The first one is the area of a sector. So if I happen to have a circle and I take out a triangular portion, like a pizza slice, the area of the remaining portion there is going to be, or even the pizza slice, depends on how you look at it, one minus the other, is that it's 1/2 times the radius squared times the angle creating that sector. But it has to be in radians, which if we look at our question here, the angle from this line all the way over to this line, they want that angle, which is the angle of the big sector. So in this question here, we are actually working with this sector right over here. Okay? And so its area is going to be 1/2, and they give us a radius, 4.75 squared, times the angle, which is actually going to be, which I messed up. I wrote here as x, but in reality, we need to fix that. That needs to be 2 pi minus x, or 360 degrees minus x. I apologize for that. I got a little sloppy last night. Alrighty. Well, they tell us that the area of this sector in orange is going to be 5 times the area of that triangle. Now, because we're really interested in this angle right here, let's make sure that we set up our triangle with this angle in reference. When working with isosceles triangles, 2 sides are going to be equal to each other, and the strategy is cut it in half to work with a right triangle. So this right triangle is going to have an angle of x over 2, and we know the radius. Now, we've talked about how if we have a triangle, how to get the area based off of a side length and the angle. So here's the triangle that we're working with here. It has a radius of 4.75 from the circle it's referencing, and here we're working with the angle x over 2. So the height of this triangle would be adjacent to this angle, and so it's going to be hypotenuse times cosine of the angle x over 2. This side is opposite the side length, so we're going to use sine for this guy, and it's going to be hypotenuse times sine of x over 2. Putting it all together, the area of this triangle is going to be the hypotenuse, which I'm calling x squared. Be very careful, because these references change based off of the question. The question is calling the angle in question x. Here I'm just saying a side length x for a triangle, okay, or the hypotenuse. A hypotenuse squared times sine of the angle times cosine of the angle. And the angle in this question is x over 2. All right, sorry about that. Probably got you guys dizzy. The easiest way to do this question is throw it into the solver. So 1/2 r squared theta, 2 pi minus x, is going to equal 5 times 1/2 times the side squared times cosine of x over 2 times sine of x over 2. But that's only going to give us the area of one of these blue triangles. We need to double it because of the left side over here. You throw that into your solver, stick a fork in it, we're almost done. Last one is our parallelogram. To get the area of a parallelogram, and that's what they want in this question, there are 2 popular formulas that we can use. If they gave us the side lengths, it would be this base times a perpendicular height, which would be this side length, A, times sine of the angle phi. But they didn't give us that in this problem. They gave us the diagonals. And the area of a parallelogram given the diagonals is 1/2 the product of the 2 diagonals, diagonal 1 times diagonal 2, times sine of the angle between the diagonals. Now what we find out is it doesn't matter which angle they give you. They could give you the angle at the top or the angle at the side. And this would be 180 minus theta. Now because of the way sine works, sine of an angle and sine of 180 minus that angle are going to be the same thing. So thankfully here, if you're wondering, well, what do I do? Yeah, just use that angle. All right. Okay. Thank you, everybody. We're officially done with these questions. Thank you again.